Alright, we're trying to solve a square root equation, and to do that we need to isolate the square root. But there are two square roots, so we can only isolate one at a time. I usually like to isolate the more complicated one, 3x plus 1, instead of x plus 4, but it doesn't matter. So I'm going to isolate the square root of 3x plus 1, and then add the square root of x plus 4 to both sides. So I'm going to write that as 1 plus the square root of x plus 4 on the right hand side. Now that we've isolated at least one square root, then we square both sides. Remember, when you square both sides, it's extremely important to remember to check your solutions. You might get extraneous roots. So on the left-hand side, when you're squaring the square root, you get what's right under that square root. So our answer is going to be just 3x plus 1. But on the right-hand side, this is a binomial squared. This is 1 plus the square roots of x plus 4 times another 1 plus the square root of x plus 4. You do not have to write this out, but I'm just doing it for people who like to do it that way. So I have on the left still 3x plus 1, and I do the FOIL method. 1 times 1 is 1. Outer term, 1 times square root of x plus 4 is square root of x plus 4. Remember, there is a coefficient of 1. I usually don't write that. Plus the inner term, another square root of x plus 4. And the last term, now what you're doing is multiplying a square root of x plus 4 times a square root of x plus 4. So you get what's underneath that square root, which is just, whoops, I don't know what happened here, sorry, is just an x plus 4. Okay, so you might notice that the square roots are on the right-hand side of the equation. So I'm going to subtract this x from both sides. All right. And then I'm also want to subtract the 1 and subtract 4 from both sides. Notice if you subtract 1, it goes away. But if I subtract 4, I've got another minus 4 that I can't really show. So I'm not going to put that here because it'd be kind of confusing. And what I have here is 2x on this side. And then this plus 4, if I subtract 4 from both sides, I'll have 2x minus 4. And then on the right-hand side, all I have left is the 2 square roots of x plus 4. Remember, that's like m plus m, or if you want to see it, the coefficients are 1, so you're going to have 2 of those. So I have 2 square root of x plus 4. Maybe what I'll do is leave this minus 4 for the next step, just to make sure I'm not confusing anybody. So if that that plus 4 is still there, I could subtract it on the next step. That's up to you when you want to do that. Go down a little bit. So we have 2x minus 4 equals 2 square roots of x plus 4. Now, you've isolated the square root term, and you can go ahead and square it as it is right now, but there is a coefficient of 2, and if I divide both sides of the equation by 2, I won't get any fractions over here, so I'm going to go ahead and do that. So I divide every term on both sides by 2. Then I get a little bit easier numbers here. Sorry. Having technical problems here. So we have x minus 2 equals, now these 2's cancel, right? So I just have the square root of x plus 4. And it's isolated. So now I do the whole procedure over again. I'm going to square both sides to get rid of this square root. And I'm going to do this a little bit faster. X minus 2 times x minus 2, you could do it on scratch paper. X squared, the middle term is going to be minus 4x because you'll have a negative 2x and a negative 2x again. So this will be x squared minus 4x plus 4. And over here, you're squaring the square root. You get what's inside, x plus 4. Now I have a quadratic. have an x squared. That means you need to set the equation equal to 0 and factor. So if I subtract x and 4 from both sides, I'll have 0 on the right-hand side, which is x squared minus 5x equals 0. And that factors easily because all there is a common factor of x. Finally, you get two possibilities, either x equals 0 or x minus 5 equals 0, which means x is 5. But you need to check. All right, so important thing is need to check. All right, so now we have to go back up to the original. All right, so let's check x equals 0. So I need to put in 0 for x in the original equation. 3 times 0 plus 1 minus the square root of 0 plus 4. So let's see, 0 plus 1 is 1. 0 plus 4 is 4. Square root of 1 is 1. Square root of 4 is 2. 1 minus 2 is negative 1. On the right hand, I have 1. So no, x equals 0 is not a solution. Let's try 5. So we have square root of 3 times 5 plus 1 and minus square root of 5 plus 4. So 3 times 5 is 15. 15 plus 1 is 16. So square root of 16 minus 5 plus 4 is 9 minus the square root of 9. Square root of 16 is 4. Square root of 9 is 3. 4 minus 3 is 1. 1 is on the other side. It does check. So this is a solution. All right, so here's our problem. Solve square root of 3x plus 1 minus square root of x plus 4 equals 1, and our solution that checked was 5.